Hope you can see the textbook page of NCERT in which enzyme catalysis is open. So enzymes are nothing but biocatalysts. If someone asks you to define what is enzyme, then you will simply say that either biocatalysts or biochemical catalysts are called as enzymes. So just like the properties of enzymes, just like the properties of catalysts, the enzymes also work in a very specific manner for a particular substrate. So enzymes are nothing but biocatalysts. Just like for every lock, there is a specific key. So any other key cannot open that particular lock. Similarly, enzymes also have a specific substrate on which it works. So based on the type of substrate on which the enzyme works, its name is kept. So enzymes are biochemical catalysts only. Now, since it is biochemical, therefore it is mostly protein plus a non-protein part. This non-protein part can be of two types: cofactor and coenzyme. Just like promoters in case of catalysts used to enhance the activity of in catalysts, similarly cofactor and coenzyme enhances the activity of the enzymes. These coenzymes are nothing but the vitamins, mostly the vitamins like vitamin B12, and these cofactors are metal ions. These are metal ions. When the enzymes work on a particular substrate, then its rear and tear takes place. This coenzyme and cofactor helps to repair that rear and tear and makes the enzyme efficient enough to work for another set of reactions. Now, based on the type of reaction the enzyme performs or helps to perform, its name is given. Like enzyme which helps to convert sugar to alcohol is called as invertase and gymase. So these two reactions are the same reactions only. Actually, these are two steps reaction in which first of all, on the sugarcane juice, invertase enzyme works and converts itself into glucose and fructose. Then on glucose, gymase enzyme, which comes out from the yeast, converts itself into ethanol and CO2 gas. Now, similarly, when starch is converted into maltose, then we name it as maltase or diastase. See, it is maltose, C12H22O11 is maltose. Now, you may say that, sir, this formula is same as that of cane sugar. Yes, they are isomers of each other. This we will be discussing in the biomolecules further. Like they have difference in the orientation of hydrogen and OH group. Hydroxyl group orientation is different. All right, so they are isomers. So we'll be seeing this also. that how their chemical formula is same, but their name is different because they are isomers. They have difference in their structure. Now maltose converts into glucose in presence of maltase. Urea converts itself into ammonia in presence of urease. Now here the conversion of milk into curd is written that this takes place in presence of lactobacilli, and lactobacilli is nothing but a bacteria, and it is acting as an enzyme. So a small amount of enzyme can lead to a huge amount of reaction, and hence it is called as it is highly efficient. Why do we call enzyme to be highly efficient? Because a small amount of enzyme can lead to large extent of reaction or large quantity of reaction. Just for an example, I can tell you, if you take a bucket of milk and if you put a drop of lemon juice, the whole bucket of milk can be curdled. This is because the water molecule, when becomes curdled, it forms acid, lactic acid, and the H plus ion further produced curdles the rest part of the milk. Similarly, it is highly specific in nature. Just like every key is specific for a lock, just like that, every enzyme is specific for a particular substrate. Now you might have noticed that during fever, we get bad taste on our mouth. We don't feel like eating. This is because when temperature of the body increases, then our enzyme also becomes weak. So the digestive enzyme or the enzymes which are there on our tongue, that becomes very different. As a result, we don't get the right taste, and even digestion problem also starts. Same is the case with the pH. The enzymes work at a optimum pH. Certain enzymes work at lower pH, certain enzymes work at higher pH. So the pH level of the surrounding of the enzyme where it has to work has to be maintained. Next, increasing the activity of activators and coenzymes. As I told you that these coenzymes are non-protein part of the enzymes and they are mostly vitamins. So these help to enhance the activity of the enzymes. When a certain enzyme work for longer time, then wear and tear of it takes place because it is also proteinaceous. These activators are nothing but the cofactors which I said. These are metal ions. These are metal ions. This we get from the minerals. Influence of inhibitors and poisons. Now, enzyme contains two sites. A molecule of enzyme contains two sites. One is the site to which the substrate can be attacked, and other side is the allosteric site. Now, towards the substrate site, if any such molecule which does the mimicry of the substrate, then what will happen? Substrate will not be able to come in contact with the enzyme and substrate will not undergo reaction. So this type of mechanism is called as poisoning of enzymes or inhibitors. This I had discussed in detail when I was talking about enzymes and the poisons over there. So inhibitors are or poisons, they are molecules which mimic the substrate or they get attached to the allosteric site and changes the structure of the enzyme, as a result of which it fails to work efficiently or fails to work completely even. Now, mechanism of the enzyme catalysis. As I was telling you that every lock has a key, similarly, enzymes also work specifically for a particular substrate. Now in this diagram, you will see that there is a key-like structure on which E is written. This E is nothing but enzyme and S is substrate. So you will see that the enzyme is attacking on the substrate and it is forming enzyme substrate complex. Further, this enzyme substrate complex, when it's freed up, then they are forming product. So this is called as lock and key hypothesis. Lock and key hypothesis. For every enzyme, if you will see the biochemical structure and the molecular mechanism of the reaction, it will be very long. This is just like an analogy at this level for you to understand how enzyme and substrate works. So the first step is that the enzyme and substrate joins together to form enzyme substrate complex. Then next, the enzyme substrate complex further decomposes to form the products and enzyme is released. Just like catalyst, even enzymes do not take part in the chemical reaction to form product. It gets freed and helps the next set of reaction to take place. Now there is a table given over here. This table we will be studying when we will be studying P block element once again. In our previous discussion, we also have discussed that Haber's process is the method by which we produce ammonia, in which iron is used as catalyst and molybdenum is used as platinum, as promoter. Similarly, for Ostwald process of manufacturing of nitric acid, ammonia is the source of nitrogen which is used in industry, is oxidized in presence of platinized asbestos as catalyst. It forms nitrogen dioxide, and it being an acidic oxide, when treated with water, forms nitric acid. Similarly, in contact process, sulfur dioxide is converted into sulfur trioxide in presence of vanadium pentoxide. If you will listen to the previous videos, I was mentioning about that. Then sulfur trioxide is made to pass through the discarded H2SO4 which comes from various industries. Now you may think that why H2SO4 is used when H2SO4 has to be prepared. This H2SO4 is the rough H2SO4 or discarded H2SO4 or dilute H2SO4, which is concentrated to form H2S2O7 is oleum. The other formula for this is H2SO4 dot SO3, fuming sulfuric acid, which when showered, which when diluted by shower of water, then each of the H2SO4 now is becoming twice of H2SO4. So the precursor was one molecule, but the product is two molecule, and that too concentrated. That is the benefit of this process. So again, it is just like a handspan sized concept that enzymes are biocatalyst. Enzyme contains two parts, protein part and non-protein part. The protein part is called as the enzyme or holoenzyme, and non-protein part is called as alloenzyme or prosthetic group. This alloenzyme or prosthetic group are non-proteinaceous and are of two types: cofactors or activators and coenzymes. Coenzymes are nothing but the vitamins attached with the enzyme, like vitamin B12, and cofactors are nothing but the minerals or metallic ions. The name of the enzymes are given based on the substrate on which it works. Like if it works on maltose, we call it maltase. If it works on urea, we call it as urease. If it inverts the molecule, we call it as invertase. All right. So in this way, it is named. So enzyme helps to increase the rate of reaction and complete the reaction in lesser time. Else it will take lots of time for the reaction to take place. Enzymes are highly efficient because in very small quantity they can result to a big amount of reaction. In your book, it is written that one molecule of enzyme may transform 1 million molecules as reactants per minute. They are highly specific because one enzyme can work on only one type of substrate, not for all other types of substrate. They work at optimum temperature because if temperature will increase, then what will happen is the protein will coagulate. The structure of protein will undergo denaturation. As a result, the activity of the enzyme will decrease. So the enzymes work in our body at a particular temperature, not even at lower temperature, not even at higher temperature. They work at an optimum pH. The alkalinity and acidity should be proper. Different acid works or different enzyme works at different alkaline level or different acidic level. Then the activity of the enzyme is increased either by activators or by coenzymes. Activators are the ions and coenzymes are the vitamins. These are non-protein part of the overall enzyme. Action of inhibitors and poison is to reduce the activity of the enzyme or to completely stop the activity of the enzyme by destroying the enzyme or by occupying the active sites of the enzyme where substrate can attach. Mechanism of working of enzyme is given by lock and key hypothesis, in which enzyme forms a complex with the substrate and converts substrate into the products. So it is as simple as that. You can go through this text material. Nothing more than it is required to be known now. And more about enzymes will again be seen in biomolecules chapter, wherein there will be repetition. There will not be much things over there. All right. So again, this topic will reappear in the chapter biomolecules. Thank you.